Okay, this is 7.2 Form K. So this is the third page of our packet. So here for number one, we just wanted to list the congruent sides and write out the proportion for our similar figures. So if these two quadrilaterals are similar, which it says they are, their corresponding angles are going to be congruent. So angle A is congruent to angle W. Angle B is congruent to angle X. Angle C is congruent to angle Y. And then angle D is congruent to angle C. Okay, so A was congruent to W. B was congruent to X. Y was congruent to C. And then D was C. Okay. AB corresponds with WX, so you can get that by looking at the diagram, or we can use the similarity statement. So AB is the first two letters, WX is the first two letters. So AB with WX, BC with XY. The next side is going to be CD with YZ. So CD corresponds with YZ. And the last side is AD, which is the first and the last letters. So AD with WZ. Okay, those are your similar sides. So all the numerators come from the first figure, all the denominators come from the second one, and you're just simply matching up the corresponding sides. AB matches up with WX, BC with XY, CD with YZ, and then AD with WZ. Okay, here we have triangles. So again, it helps to look at the similarity statement. So angle G is going to be congruent to angle K. It's not a very big K. Angle I is congruent to angle L. I with L. And then J with H. H with J. Okay. Then we want to write our proportions. So GH is going to correspond with KJ. HI is going to correspond with JL. And then GI is going to correspond with GIKL. So those are your proportions. Okay. The next four, they want us to determine if the polygons are similar. If so, they want a similarity statement and a scale factor. If not, we want to explain why. So in order to show that figures are similar, we need to do two things. We need to show that that their corresponding angles are congruent and that their sides are proportional. So to show that the angles are congruent here for number 3, we know C is congruent to Q. Okay, we know D and R. Angle D is congruent to angle R. Okay, we know angle F is congruent to angle T. And we know angle E is congruent to angle S. Okay, so let's check, right? Angles are congruent. Now we need to check the sides. So 6 is going to correspond with 8. 3 is going to correspond with 4. 6 with 8. And then 3 with 4, right? So 6 and 8, 3 and 4, 6 and 8, 3 and 4. And those ratios are not equal. So, they are equal. 6 over 8, if we put that in the calculator or we reduce the fraction, we get 3 over 4. So all 4 of these are going to equal 3 over 4, right? If you reduce the fractions, they're all going to be 3 over 4 or 0.75. So since they're all equal, we say yes. Triangle or the quadrilaterals, the figures are similar. They're similar because their angles are congruent and sides are proportional. We know the sides are proportional because the ratio of all the sides are equal. Okay, since all the ratios are equal, all those sides are proportional. Okay, scale factor is simply what the ratio is. So The ratio here is going to be 3 over 4. Right? Or you could do 4 over 3. So this figure here is 3/4 the size of this one. This one is 4/3 the size of the smaller one. Right, you got to multiply each of these by 3/4 to get these numbers, or multiply these by 4/3 to get these numbers. Okay? It's the magnitude change between them. And the last thing is we need a similarity statement. So we can name this figure a number of different ways, right? You want to go clockwise or counterclockwise, starting from one point. So let's just start at C and call it CD, EF. Okay, C corresponds with Q, so we're going to say Q, R, S, and then T. Okay, so that's your similarity statement. So they were similar because their angles were congruent and their sides were proportional. We knew their sides were, we knew the angles were congruent because of the arcs that were shown in the diagram. And we knew the sides that were proportional because all the ratio of the corresponding sides were equal. Every single one increased by 4/3 this way, or decreased by 3/4 going this way. Okay. And that ratio was the scale factor, also known as the similarity ratio. And then our similarity statement was CDEF, was similar to QRST. Number 4, they don't give us a lot, but if we just look at the sides, 8 is the smallest side of this triangle, so if they were to be proportional, 8 would match up with the smallest side of the other triangle. So 8 would match up with 3, right? It would be turned sideways. You'd have to rotate it 90 degrees. And then 12 would match up with 4. 8 over 3 does not equal 12 over 4, so we can say no. Okay. They also didn't give us angles, so we wouldn't have been able to tell because of missing angles, but we didn't need them because we know the sides are not proportional. All right, the sides have to be proportional and the angles have to be congruent. You need both. Here we're missing, we don't know about the angles, so that could or could not be congruent, but we do know that the sides are not proportional. Okay, number 5 here. So we have 4 pairs of congruent angles. They're all 90 degrees. So again, if you rotate this, L matches up with U, M with R, N with S, and O with T. So that's good. 4 pair of congruent angles. We would then have to check the sides. So 10 is the long side, so it's going to match up with the long side on the other one. So that's going to be 10 over 8. And then 4 would match up with 3. 4 is the shorter side on this one, so it's going to match up with the shorter side on this one. It turns out that those ratios are not equal, so these figures are not similar. They're not the same shape. Okay? They're different shapes. Similar figures are the same shape, different sizes. These are just not the same shape. Okay, number 6. So we got to check angles first. So we got to find our missing angles. So to find missing angles, we know 3 angles of a triangle add up to 180. So we need to do 180 minus, let's do it over here, 180 minus 49 minus 88. Okay, that's going to give us 50 and 90 is what it's going to give us 43. Okay, and then we can do this one, 180 minus 43 minus 49. That's minus 15, 40, 90, 88. So this is going to be 88. Okay. So do we have 3 pairs of congruent angles? Yes. C matches up with I. They're both 43 degrees. D matches up with J. They're both 49 degrees. And B matches up with H. They're both 88 degrees. So we have 3 pairs of congruent angles. Now we need to check the sides. Okay, so you pick one side over here. I'm going to pick 9. Actually, I'm going to pick 6. Doesn't matter what you pick, but I'm going to pick 6. Okay, 6 is, so two ways to tell which sides pair up. So 6 is between the 49 degrees and the 88 degrees. So it's going to match up with the one between the 88 and 49 on the other side, which is 4. Or I think the easier way to think of it is if they're going to be proportional, the smallest side of one figure is going to match up with the smallest side of the other. So the small side of this one is 6, is going to match up with the small side of the other one, which is 4. 9 is in the middle. 6 is the one in the middle over here. Or you could do it's between 88 and 43. So between 88 and 43 is 6. And then the last one is the largest side is also between 49 and 43. So the largest side here, or between 49 and 43, is going to be 12 with 8. Okay, you can reduce these fractions. You get 3 over 2, 3 over 2, and 3 over 2. So you have 3 pair of angles that are congruent and 3 sides that are proportional. They're proportional because the ratios are equal. So these are similar. They're the same shape because their angles are the same and their sides are proportional by a factor of 1.5. Right? 3 over 2 is 1.5. So this figure here is 1.5 times the size of this one. Right, or you can think of this one as being 2/3 the size of this one. So all the sides are going up by the same magnitude. So we say that they are proportional. So these are similar, yes. Scale factor is 1.5 or 3 over 2. You could also put 2 over 3. And then your similarity statement. So how about BCD? Triangle BCD is similar to triangle HIJ. So triangle BCD is similar to triangle HIJ. Let's go to the next set of problems. Okay, the polygons are similar. Find the value of each variable. So since they're similar, we know angles are congruent and sides are proportional. They are giving us sides here. So let's match up all of our sides. So 12 is between the 1 arc and the 2 arcs, so 12 matches up with, let's use a different color. 12 matches up with 18. X matches up with 9. 4 matches up with 6. And then Y matches up with 12. We got to solve for X and Y now, so what we're going to do is pick 2 ratios, right? We can't cross multiply with all these different ratios, so we just want to pick 2 of them. So for solving for X, we want to use the one with the X in it, so that's X over 9. And then we want to pick one of the ones without a variable. So you can pick 12 over 18 or 4 over 6. I like 4 over 6 because they're smaller numbers, so I'm going to choose 4 over 6. Okay. And then you cross multiply. So 6x equals, right, 6 times x, and then 9 times 4. So 6x is 36, divided by 6, we get x equals 6. To solve for y, we pick the one with y in it, so y over 12. Okay, and then again, I like 4 over 6 because the numbers are much smaller than 12 over 18, but you can pick 12 over 18 if you want to. I'm going to pick 4 over 6 though, because I like smaller numbers, easier to work with. Cross multiply, so you got 6y equals 48. Divide by 6, y is going to be equal to 8. If you want to check your answer, we can plug them back in. So this would be 6 over 9 and 8 over 12. Okay, and all of these reduce to 2 over 3. Are they equal? You can put them all in the calculator. It should all give you 2/3. So those are all going to be equal. So we know our answers are good. So x is 6 and y is 8. Okay, over here, you can fill in vertical angles if it helps you think about it. The A is between the 2 and the 3, so A is going to match up with 12. B is going to match up with 10, and then 9 matches up with 15. Okay, if we want to solve for A, we pick the one with the A in it, so A over 12. And then you want to pick the one that does not have any variables. Right, this is an A. Cross multiply, so you get 15A equals 12 times 9 is going to be 108. Then divide by 15, 7.2, I believe. Fifteen goes into 96 times, so it goes into 105 7 times. And then 3 out of 15 is 0.1. 3 out of 15 is 1 in 5. Oh no, I'm right, 0.2, 7.2. Okay, and then for B, we want to do B over 10. And we'll do 9 over 15. So cross multiply, you get 15B equals 9 times 10 is 90. Divide by 15, B is going to be equal to 6. Okay, if we plug those back in, 7.2 and 6, we should get 3 over 5 for all of those. All right. And then the other side. Okay, we want to enlarge a 3 by 5 photo. The paper you print is on an 8.5 by 14 inch. What is the largest size of the photo in B? It's 7.2. I was just making sure it's 7.2. Okay. So we have a 3 by 5, and we want to enlarge it, make it bigger. Okay. So it's on an 8 by 5, 8.5 inch by 14 inch piece of paper. Okay, so the issue here is 8.5 divided by 14 is not the same as 3 divided by 5. So these two, if you put it on an 8.5 by 14 inch paper, it would not cover the entire thing. So what we need to do is figure out the largest size that will fit on that entire piece of paper. So we can try to fit the entire thing, the width of the entire thing on there, and then we got to try it with the entire length. So let's try 8.5 by, we'll say Y. Okay, and then we got to try it again where we have 14 by, so we want to try both ways. Okay, and see which one is going to fit on our piece of paper. So we either want to maximize the length or we want to maximize the width. We can't maximize both because they are not proportional, so we can't maximize both the length and the width. So we want to find out what would happen if we maximize the length, if we maximize the width. Right, so let's solve for x and y. So if we look at our proportion here, it's going to be 3 over 8.5 equals and then 5 over y. Okay, and again, you could have done 3 over 5 equals 8.5 over y. You could have done 5 over y equals 3 over 8.5. Y over 8.5 equals 5 over 3. All of those would have been acceptable because when you cross multiply, you're going to get the same thing. We would get 3y equals 42.5. 5 times 4 is 40, and then 0.5 times 5 is 2.5, so it's 42.5. And then 42.5 divided by 3 is going to be 14 and 14.167. Okay. So if we notice here, the paper we're printing onto only has a width of 14 inches. So this one's not going to fit on the paper. So this way is not going to work. Okay, it's not going to fit on the paper. So it's going to end up being the other way. So let's see, we want to maximize the width of 14, and let's see what we get for x. Okay, so for there, our ratio would be 3 over x equals 5 over 14. Okay, and again, you could have done 3 over 5 and x over 14, 5 over 14 and 3 over x, 14 over x and 5 over 3. All of those would have worked. Because when you cross multiply, you should get 5x equals 42. When you divide by 5, 42 divided by 5, you get 8.4. And we know 8.4 is less than 8.5, so it's going to fit on the paper. So the dimensions will be 8.4 by 14. That's the largest size we can get. It's a good problem, I think, but maybe a little harder than it needed to be. Alright, so let's try 10, 11, I think are much simpler. Let's try those here. So for our class, we need to make a scale drawing using the scale 1 inch is 5 feet. The Parthenon is 228 feet long, so if you have a scale, and then you have the big thing, if your scale, or your big thing is 228 feet long, the scale is 5 feet, right? 1 inch is 5 feet on the scale. Okay. How many inches would the drawing be on the scale? So they give you the 1 ratio, 1 inch to 5 feet. Okay. They give you the whole thing over here is 228 feet. Right. So 1 inch is to 5 feet as how many inches is to 228 feet? Every 5 feet is 1 inch. So how many inches is 228 feet? Okay, you could have also done 1 over x equals 5 over 228. That would have worked too. We cross multiply, we get 228 equals 5x. Okay, this would be feet inches, and that would be feet. So the feet could cancel out. Then we divide by 5, so 228 divided by 5, and we get 45.6. So 45.6 divided by 228 should be the same as 1 over 2. I'm sorry, 1 over 5, which is 0.2, so we're good. So in your drawing, it should have been in inches. Ella is reading a map of the scale of 1 to 20. So they're giving us, again, 1 ratio. 1 inch is 20 miles. Okay. On the map, the distance Ella is driving is 4.25 inches. And we want to know how many miles that's going to be on the map, or in real life. right? So every inch on the map equals 20 miles in real life, in reality. And so every 4.25 inches is gonna be how many miles? So cross multiply, we get x equals 20 times 4.25 is gonna be 80, 85.25. Well, it's gonna be 85 spot on. I don't know what I'm thinking. Dehydrated. That's just an excuse. There's no excuse for having gotten that wrong. I don't know why I said 85.25. 85 miles. We scroll down here, we have two triangles here. Okay, they tell us they're similar and they're giving us sides. So we know that similar triangles have proportional sides, so we can set up a proportion. So 3 is JK. JK is going to match up with QR, so that's 3 over 9, right? You got to rotate it. So JK matches up with QR, corresponds with QR. So 3 over 9. And then JL, Z, it's going to match up with QS, which is Z plus 4. Right, so it's rotated. JL, or JK matches up with QR, and then JL matches up with QS. Okay, you have your ratios, now you can cross multiply and solve. So 3 times Z plus 4 equals 9 times Z. You distribute, that's 3Z plus 12 equals 9Z. Subtract 3Z, you get 12 equals 6Z. Divide by 6, you're going to get Z equals 2. So if you plug that in, 3 over 9 should equal 2 over 6. Right? Those both equal 1/3, we're good. Oh, they want the scale factor. Well, the scale factor is going to be 1 over 3, right? 3 over 9 is 1/3. 2 over 2 plus 4, that's 2 over 6, is going to be 1/3. Okay. The scale factor from A, B, C, D to E, F, G is 7 to 20. So that means that this one is 7/20ths the size of this one. Okay. So the scale factor the other way is going to be reversed. It's going to be 20 over 7. Okay, this one's 7/20ths the size of this one, then this one is 27ths the size of that one. 14 through 19, we went over, well, we went over all of it in class, really, but let's do this. So angle N is 49. We know angle N is congruent to angle W, so that's also going to be 49. We know angle O is congruent to angle X, so since O is 58, X is also 58. We know the 3 angles of a triangle add up to 180, so 180 minus 58 minus 49 is going to give us 73. Right, and same thing over here, you can get 73. So angles are congruent. It tells us they're similar. We know if they're similar, the angles are congruent. So X is going to be 58, and Y is going to be 73. Okay, now we can do our sides. I'm going to put an X and a Y for our missing pieces. Okay, we know that 6 is between the 49 and the 58. So 6 is going to correspond with Y. You can also use the similarity statement. So NO is similar to, or corresponds with WX, so 6 over Y. NP corresponds with WY, so that's going to be X over 12. Right, and then OP matches up with XY, so that's 4 over 10. Okay, we want to solve for X, so we pick the two, so we pick 2 ratios. We want to pick one with the X in it, because that's what we're solving for. And then we want to pick 4 over 10, because if we pick 6 over Y, then we have 2 variables in our equation, and we don't want 2 variables. You can't solve one equation with two different variables. So we want to pick the 4 over 10. Okay, and then to solve that, you cross multiply, so you're going to get 10x equals 48. 12 times 4 is 48. Divided by 10, x is going to be 4.8. Okay. To solve for y, we're going to pick 6 over y. Okay, and again, I'm going to pick 4 over 10 because it doesn't have any other variables. We could plug x back in and do 4.8 over 12, but I'm just going to stick with 4 over 10. We cross multiply, so you get 60 equals 4y. Divide by 4, you're going to get 15 equals y. So we know x here is 4.8, and we know y is 15. And then we can fill stuff in. So our scale factor, or to check and see if those answers are right, we can then plug them back in. So 6 over 15, 4.8 over 12, all of those are going to be equal to 2 over 5, right? 4 divided by 10 is 2/5. 4.8 divided by 12 is 2/5. 6 divided by 15 is 2/5. They all equal 0.4 or 2/5. So our scale factor here is 2/5, okay, or 5 over 2. This one is 2/5 the size of this one. This one is 5 halves the size of this one. Okay, our ratio, all your ratios should equal 2/5, right? 4.8 divided by 12 is 2/5. Wx we solved for is 15. That was our y. And then our x was np, which was 4.8. Okay, company makes rugs. Their smallest rug is 2 feet by 3 feet, a rectangle. Oops. Okay, the largest rug is a similar rectangle. One side is 18 feet, so we don't know if the large side is 18 feet or we don't know if the short side is 18 feet. So we got to try it both ways. Okay, so let's try with the short side. Okay, and then we can try with it as the long side. Right, so we know it's similar to the smaller rug. They're rectangles. They all have right angles, so angles are congruent. And then sides are proportional. So if we have 2 by 3 and 18 is the short side, we're going to have 2 over 3 equals 18 over x. You could also do 2 over 18 equals 3 over x. Okay, or 18 over 2 equals x over 3, or x over 18 equals 3 over 2. All those would work. When you cross multiply there, you're going to get 2x equals 54. Divided by 2, x is going to be 27. Okay. So that's one possibility. If 18 is the shorter side, it's going to be 18 by 27. Those are going to be your dimensions. Okay, if it's the longer side though, we're going to do 2 over 3 equals y over 18. Okay, you could also do 2 over y equals 3 over 18. You could do y over y over 2 equals 18 over 3. You can do 18 over y equals 3 over 2. Whenever you cross multiply any of those 4 options, you're going to get 3y equals 36. So divided by 3, y is going to equal 12. So we have 12 by 18. Right, so 12 divided by 18 is 2/3. 18 divided by 27 is 2/3. And so these rugs each have a side length of 18, and they're proportional to, similar to the rug that had sides of 2 and 3. Okay, and that is form K, right? Yep, page 3, form K.